See, don't do this so that because at least you should respond to the homework because it is good for you itself. Because unless and until your basic will be cleared, you will not be able to understood the next syllabus. Correct, na? आवाज येते ना माझा?
Yes, ma'am.
No, madam.
So I hope you will be doing your homework. Otherwise, it will be difficult for you only to find out those answers at the time of the seminar because these type of questions we are going to ask you. And if you are not going to answer any questions from the teachers as well as from the student, because you also have to questions your friend and your classmate that if suppose someone's topic is vector space or if it is exact differential equation, you have to ask why this condition is called exact differential equation and all. So these type of a question you must ask whenever you are going to attend the seminars. Okay, and if you are not going to answer, you definitely are not going to get the 5 marks because 10 marks are for the matter collection, 10 marks for the presentation, and 5 marks are reserved for your question answer session. Okay. I hope you are knowing on the Thursday you have to upload your seminar report on the seminar group 1 assignment created, and in every time we are going to create one assignment, that is those student have to upload this. Okay. Seminars group 2, group 3 and so on. Okay. So let us go for the next point in our syllabus. Constraints. I hope you have heard constraints or limitations. These type of a term we have heard. Okay, constraints are nothing but the limitations or geometric restriction on the motion of a particle or the system of particle. Right. So if you are having the one system of particle, so if it is moving somewhere, then whatever the type of a constraints are there or the limitations on the motion of a particle are called the constraint. Let us go with one example. So if suppose you are going somewhere or if your fan is working there or anything else, any type of a things which is happening in the universe, it consists of some limitations. Correct. Just the limitations may be any type of a limitation. Correct, just like motion of electric fan or motion of one sphere, motion of a simple pendulum. If you can see any type of a motion, it consists of some external forces that are limiting the motion. Okay, so these type of limitations or geometric restriction we are going to call it as a constraint. Okay, the constraints are the limitations or geometric restriction on the motion of a particle or the system of particle. It may consist of with a single particle or it may be consisting with the system of a particle. Okay. So these type of a relation with the between the coordinate time t are always possible to express in the form of f of xi, yi, zi, t, which is greater or equal by 0. Okay. So here we r denotes the number of constraint. Okay. Where is r? Actually, we are having some equation. Just like suppose particle are moving on the surface of a sphere. Okay, some particle on the moving on the surface of a sphere, right? So if we are considering the sphere, obviously it will be consisting of a three-dimensional system. Okay, so it will consist of xi, yi, zi. What is the relation between x, y, z in the sphere? Okay, what is the relation in the x, y, z in the sphere? How we write the equation of a sphere? X minus a square plus y minus b square plus z minus c square is equals to some r square, right? Where r is the radius of a sphere, a, b, c are nothing but your center of a sphere, correct? So these type of things we are going to observe. That means there is some relation in between x, y, z, And what we are considering, we are having one particle moving on the surface of a sphere. Okay, so what is the condition for that particle? If it is moving on the surface of a sphere, its distance from the origin must be greater than or equal to radius. Okay, so these type of a relation, if you are able to express in the form, that means it is some function of x, y, z, and t. Just xi, instead of taking x, y, z, it is taken xi, yi, and zi. And xi, yi, zi are the coordinates of ith particle of the system. So here it is considered with the ith particle of the system. Okay, if you are having single particle, you can say directly x, y, and z, and t is a time. Okay. So, what are the constraints? These are simply limitations or restrictions, geometric restriction on the motion of a particle. Now, how we can say it is geometric restriction? Uh, just like we have considered the example of a sphere. We are saying that particle is moving on the surface of a sphere. If particle is moving on the surface of a sphere, what is the geometric restriction? That particle may be greater than that means it the distance is fixed out. Correct ना? कुणाचा माइक चालू आहे बहुतेक. वैभवी कुंभार, प्लीज अनम्यूट yourself. So please, whenever we are having a lecture, try to do your mic should be off. You should be unmute yourself, right? Otherwise, it will be problem because we are recording these lectures. Disturbance for you people also. Okay. So here, what is the restriction on that particle? It may be having a distance from the origin is greater than or equal to radius. That is what a geometric restriction. Okay. Let us go through some examples of the constraint. Motion of an electric fan. Okay. What is the restriction on the motion of electric fan? Motion of an electric fan is such that it moves along a clockwise direction. If you have observed, it is restricted to move in a clockwise direction. Right. So that is what the limitations or restriction on the motion of a electric fan. And that is called a constraint. Okay. Motion of an electric fan. You can observe the motion of a fan and you can see it may be in the clockwise direction, and hence we can say that that is what a restriction on the motion of that particle. Okay. So hence let us go for the next. Motion of a rigid body is such that the distance between any two particle is always constant during the motion. Okay. Suppose a particle is moving, or if suppose you are having one bench. Okay. I hope you have done this many times. Uh, okay, if you are going to move that bench or table anywhere else, so what you have to do, you have to put, you have to uh, keep it some another place. Okay. अगर आपको उसको उठा के किसी जगह पे रखना है तो आपको कुछ लोग लगेंगे ना, डिपेंडिंग ऑन द weight of that bench or table. Okay. So you are applying some amount of force on that so that you can move it to your desired place. Okay. So what is that rigid body? Rigid body in the sense we are going to discuss this later on in the fourth chapter. What is a rigid body? Actually, we can say rigid body is a thing which having the distance between any two particle or any three particle from that rigid body is fixed out in during the motion. Okay. अगर आप टेबल उठा के कहीं पे रख रहे हो तो whether whatever the distance between the two particle at initial position will be the same for after moving to some another position. रहता है क्या same distance? Suppose
Yes,
we
ma'am.
one box. Okay, let us assume that we are having a duster. Okay, if this duster I have moved to some another position. Okay, so if we are having these 2 points, so distance between these 2 points will be same after moving to some another position. Correct? So that is what the motion of a rigid body is such that distance between any two particles is always constant during the motion. If you can apply any type of a motion for this duster, you can apply rotational motion, you can apply any type of a translation motion, any type of a motion if you apply, then the distance between any two particles of this will not be changing unless and until you are going to break. अगर आपने इसको तोड़ दिया तभी उस पार्टिकल का डिस्टेंस चेंज होगा अदरवाइज any two particle if you are going to take the distance between that particles will be same after moving to some another point. Okay, it may be rotational motion, translation motion, circular motion, any type of a motion if you take, the distance between any two particles is always fixed out. Okay, and that is what a geometric restriction. Okay, that is distance. Suppose I am taking a particle a1 a2 or p1 p2, so let us assume the distance between particle p1 p2 is r1, and that is what a fixed part, and that is but geometrical restriction. Okay, next we have to see motion of a simple pendulum. No doubt this we will see in detail what is a restriction and all. Motion of a particle on the surface of a sphere. This also we have seen. Motion of a gas molecule inside the container. Just you can consider the LPG gas cylinder which is coming to your home. आप यूज करते हो ना होम घर पे. Actually, why we called LPG? It is liquid petroleum gas, no? So due to pressure itself, if we apply, आप जब बटन ऑन करते हो आपका स्टोव का, तभी वो गैस में कन्वर्ट होता है, करेक्ट? सो जब तक वो सिलेंडर में होता है तब तक वो लिक्विड के फॉर्म में होता है, राइट? सो मोशन ऑफ अ गैस मॉलिक्यूल इनसाइड द कंटेनर. Okay, if we are considering a single container in which it may consist of a gas molecule. So what is that restriction on the gas molecule inside the container? You can take a cylinder, any type of a things. Okay, you can consider the sphere, you can consider the football or anything else. Football में भी आप हवा भरते हो ना. So actually, whatever the gas molecules are there in the football, so what is the restriction on them? They are moving, no doubt. But what is the restriction on the motion of those particles inside the football? What is the restriction is they cannot go outside that football unless until your football is going to burst. Okay, अगर वो टूटता है या फूटता है तभी वो बाहर जा सकते हैं, right? So the area for the motion of those particles is fixed out, right? We understood what is a constraint or limitations restriction. So if you understood, let us go for the classification or the types. Is there any doubt?
No, ma'am.
Okay. Let us go for next one, that is classification of a constraint or the types of constraint. Actually, there are 4 types of a constraint. First is holonomic, second is non-holonomic, third is cleronomic and rheonomic. Okay. Now let us go one by one. What is a holonomic constraint, non-holonomic constraint, scleronomic and rheonomic. Okay. I hope there must not be any problem related to my teaching or anything else. If you have, you can say me at any stage, right? So, what is a holonomic constraint? The constraint relation. That means whatever the relation we have seen just now. That means if you are having any type of a system or particle, rigid body, सभी में कुछ ना कुछ restriction है, right? If you are having a rigid body, there is restriction than any two particle. If you take the distance between that particle is always fixed out. That is what a restriction we have written. F of xi y z I is t, right? That is a position of ith particle. So here constraint relation when it is expressible in terms of equation. Okay, that is just like our equation of a sphere. What is an equation of a sphere? X square plus y square plus z square is equal to r square is an equation of a sphere with center at origin, that is 0 0 0, and the radius is r. And if you take any other origin, then it is x minus a square plus y minus b square plus z minus c square. So constraint relation, when it is expressible in terms of equation, are called as a holonomic constraint. Otherwise, they are called as a non-holonomic constraint. That means if constraint cannot be expressed in terms of the equation, okay, if it is not possible to explain the constraint in terms of a equation, okay, it may be less than or greater than, it will not be equal to, correct? So what is an example of a holonomic constraint? Motion of a rigid body is such that distance between any two particle is fixed out. Okay, so what we can say, constraint relation can be given at xi minus xj bracket square yi minus yj bracket square zy minus zj square is equal to some constant. What is this formula? This is nothing but the distance formula, na? Distance between
Yes,
the,
ma'am.
what is the distance formula? That is, we are having two particle xi y zi is a coordinate of first particle, xj yj and zj is the coordinate of a second particle. So this distance formula gives us that whatever the motion of a rigid body we are having, it has some restriction. What is that restriction? That is what our distance formula, that is distance between them is always constant if you are applying any type of a motion. That is what we called a holonomic constraint. Holonomic constraint means what? They can be the constraint relation can be expressed in terms of a equation. Okay, constraint relation can be expressed in terms of a equation. Okay, so here we have seen that this is the distance between ith and jth particle of the system. Okay, so the constraint involved in the motion of a simple pendulum. Okay, what is the restriction on the simple pendulum? I hope you have studied the simple pendulum, compound pendulum. If you are having the physics as a part of a subject for your BSc, we have done the experiment also. Okay. So what is the restriction? We have this equation x square plus y square is equal to L square. What is L? L is the length of that pendulum. And this is what your x-axis and this is y, and what is the consideration? X square plus y square is L square by using our right. What is a law by which we are going to use this? X square plus y square is equal to L square.
Pythagoras.
Due to Pythagoras theorem, we can say this. Okay, as the word Pythagoras theorem is coming, so are you knowing how in how many ways we can prove the Pythagoras theorem, or is it only one way to prove the Pythagoras theorem by those whatever the study you have done for Pythagoras theorem? Okay, this will be also homework for you people, that there are how many ways to prove the Pythagoras theorem. There are more than 200 ways to prove the Pythagoras theorem. I'm not saying that you should study all those 200 ways, but you should know as a mathematician that because Pythagoras theorem is a very big basic thing, or the first theorem that we have studied anywhere, right? So, with the help of Pythagoras theorem, we can say x square plus y square is equals to L square, right? The next example is constraint involved in the motion of a bead. Actually, this is what a small piece of a glass or wood. We are having a glass or wood. वो जो आपके पास wood है या लकड़ी का टुकड़ा है, उसके अंदर एक होल करना है और उस पर से एक सर्कुलर वायर और कोई धागा वगैरह डालना है, right? So whatever the motion we are having, that is what having a restriction. What is the restriction? Radius with that specified radius, because whenever you are going to take any wire, right? So that wire will be with some length. Okay, that length is fixed out, and that is what a geometric restriction. What we have done, we are having a wood and we have done a small hole through it along a circular wire. That means आपको वो उस hole में से आपको एक circular wire or any you can have a thread also. You can put it on of a radius a is given. Okay, that is what a r is equal to a is a relation going to tell you that it is a holonomic constraint. That means it can be expressed in the form of a equation. Here also the motion of a simple pendulum we have written in the form of a equation, that is x square plus y square is equals to L square. So you can see the image here. We are having this wooden particle. From that we have one wire, or we can say it is some thread, so we can put it, and the motion of that whatever the wood we have, it will be restricted to move in the wire itself. What is the specified radius is equals to some constant a. So that is what a restriction on the motion of that wood particle, that it can move in this specified area, and that is called a holonomic constraint. Okay, now let us go for the examples of a non-holonomic constraint. In the case of a motion of a gas particle inside the container, we can say, now I have told you that we are having a, if suppose gas particle is in there inside the container, if we can consider any football or any ball or koi balloon, if you're having a balloon, so what is the restriction on them, that they cannot come outside, and what is the restriction, they can move in that particular area. And what is that particular area, if you are considering the uh, circle of a radius a, then what is the restriction, r is less equal by a, that is distance covered by that particle is, we are assuming r, and a is a radius of that circle. If we are considering container here. Okay, if you consider the football, then we can consider with a sphere. Okay, so what is the restriction on the that gas particle inside that sphere, that we can consider is that distance r that is moved by that particle will be always less equal by a. Okay, what is a? A is the radius of that sphere. Okay, so that is what we can say, it is non-holonomic constraint. That means it cannot be written in the form of a equation. So it is either less than or greater than, or we may sometimes say that it is equality. But always it will not be equal, hence it is not considered in the holonomic constraint. Okay, let us go for the next one is the constraint involved in the motion of a particle on the surface of a sphere with radius a. And what is the inequality hold is, again r is less equal by a. Okay, so you can consider the examples of these non-holonomic constraint. Is there any doubt for holonomic and non-holonomic constraint?
No, ma'am.
Okay, let us go for the next one is scleronomic constraint. What is a scleronomic constraint? The constraint are called scleronomic if it is not involving the time t. Okay, always whenever you are having the motion, it may not be depending on time, it may be depending on time. Okay, if it is not depending on time, then it is called a scleronomic constraint. And rheonomic constraint means what? It is depending on the time. And the example for that you can consider is a एलपीजी गैस सिलेंडर, शुगर फैक्ट्री में अगर आपने कभी देखा होगा, तो वेन एवर दे आर गोइंग टू फिल अप दैट जार, अगर आप वो पोते वगैरह भरते हैं ना वो, so उसके लिए सभी ऑटोमेटिक सिस्टम है, राइट? So whenever I hope you have heard, you can be you can see it on the YouTube also. Sugar factory LPG gas cylinders का, right? What is a procedure for LPG gas cylinder? वो एक मशीन टाइप होता है जहाँ पे एक प्रोसीजर होता है, दैट मीन वहाँ पे कोई गैस सिलेंडर खाली होता है, वो अपने आप आगे चला जाता है ना, दे आर हैविंग द सीक्वेंस ऑफ गैस सिलेंडर, और ऊपर से कोई एक ऐसे प्रेशर से वो हवा, सॉरी लिक्विड भरते हैं और वो आगे जाता है और उसको फिक्स करके आगे भेज देते हैं, राइट? यूट्यूब पे आपने देखा होगा मेनी टाइप, इन समटाइम इट इज there in advertises also, sometime it is a construction of some object they are giving, just like the for सॉस की बॉटल की, अगर कोई भी टाइप का हो, अगर किसी भी टाइप का कोई चीज है, तो अगर वो मैन्युफैक्चरिंग अगर किसी कंपनी में, बिग कंपनी में होता है, तो उसको एक प्रोसेस होता है, दैट मीन्स number of things are arranged and they are going in the sequence. So what is that, there is a time restriction that, right? उसी पर्टिकुलर टाइम में आपका एलपीजी गैस सिलेंडर भरेगा और वो आगे जाएगा और उसके बाद उसका आगे का प्रोसेस होगा, करेक्ट? सो ऑल the above examples are the example of a scleronomic constraint, because हमने जो अभी तक देखे वो scleronomic, जहाँ पे टाइम की जरूरत नहीं है, राइट? सो what is called a rheonomic, in which time is required. That means constraint equations or constraints are depending on the time. Okay, have you understood?
Yes, ma'am.
Okay, let me go for the next one is degrees of freedom and generalized coordinate. So be concentrate on this. Those because again I am repeating that this is a very important point for, because whatever the examples, whatever the geometric figures we are going to calculate with the help of a degrees of freedom and generalized coordinate only. Okay, so you should listen it carefully. What is given to us? Degrees of freedom. Okay, number of degrees of freedom is each possible number of linearly independent coordinate which are used to describe the motion of a system of a particle by taking account into of a constraint. Right. So what is given to us? Number of degrees of freedom. What is the number of degrees of freedom? Number of degrees of freedom is the least possible number of linearly independent coordinates which are used to describe the motion of a particle. Okay. Number of linearly independent coordinate. I hope you have heard about the linearly independentness, right? In the basis, in the vector space. What is a basis? झालंय ना वेक्टर स्पेस.
Yes, ma'am.
So what is a basis? येत नाही कोणालाही डेफिनेशन बेसिसची, बेसिस डायमेन्शन.
बेसिस म्हणजे लिनियर इंडिपेंडेंट सेट असला पाहिजे जो वेक्टर स्पेसला जनरेट करेल.
What the
म्हणजे
word you
स्पॅन
are
ऑफ
using for
स्पॅन ऑफ
generate?
एस इज इक्वल टू जी.
Spanning set and linearly independent. Okay. So actually, what we are going to assume linearly independent means what? Suppose we are if I say we are having two vectors, say 1 1 and 2 2. Can you say directly they are depending on each other? One the two tuple vector 1 1 and second one is 2 2. क्या है relation इन दोनों में, whether they are dependent or independent? R2 स्पेस में दो वेक्टर लिया है मैंने. फर्स्ट इज 1 1, सेकेंड इज 2 2.
Yes, ma'am. They are dependent.
How you can say they are dependent? Because that vector 2 2 I can write 2 comma 2 is equals to 2 times 1 1. That is, we can say the one vector can be expressed in the form of another vector with the help of some scalar, right? So whenever you are going to consider the basis, suppose we are discussing on R2 space. If I am saying that we are having the basis 1001, right? This is a standard basis for you, standard order basis. So I again here there is a question that what is called ordered basis and simply standard basis. What is the difference between ordered and standard basis? You must know this. Okay. So linearly independent set we are considering now 1001. Correct. If I am saying that I have another element also 1 1. Okay. Three vector I am having 1 1. Okay. So whenever you are having these three vector, I can say that what is the basis means what? If you can take any element from R2 space, it can be written with the help of those two basis element. What are those basis? 0 1, right? So with the help of that, I can write any element from R2 space in the form of linear combination of 1 0 and 0 1. Also, if I am taking 1 0 and 1 1 instead of taking 0 1, right? That is also forming a basis 1 1 comma 1 0. That is also going to basis. So what we are considering number of linearly independent. On another way, it is least possible number of linearly independent. So here if you can see 1 1 0 1 1 0, these are linearly dependent, right? And if you take only two 1 1 0 1 or 1 1 1 0 or 1 0 0 1, if you are going to take these type of element, we can say it is linearly independent. Or in another way, is the least possible number of linearly independent coordinate. Right? So hence, what is the degrees of freedom is? Number of degrees of freedom is least possible number of linearly independent coordinate which are used to describe the motion of a system of a particle. On considering the constraint also, you have to consider the constraint also, and then what is the degrees of freedom? Number of, that is nothing but number of degrees of freedom, that is that specified number is nothing but least possible number of linearly independent. So let us go for the example. A free particle moving in the plane can have 2 degrees of freedom. Right? Why we can say it is 2 degrees of freedom? Because if you are moving the particle on the plane, plane means what? It may be xy plane. So if you are having xy, yz or zx plane. Okay. So if we are considering the motion on the xy plane, obviously it will have a 2 coordinate, because many time in your 9th, 10th or 8th standard you have done. How you are going to plot an element? That means if you are having any element on the graph paper, if you are plotting it, obviously it will have a 2 coordinate. So hence, if a particle is moving in the plane, obviously it will have a 2 degrees of freedom. What are those 2 degrees of freedom? It is nothing but, if suppose we are moving in the xy plane, what are the 2 coordinates? It will be x and y, right? Next example is a particle moving in the space. So how many coordinates are requiring for particle? How many coordinates are required for a particle to move in the space? X, Y, Z. Correct. So simply X, Y, Z will describe where is your particle. Okay. So if we are having a particle in the space, we need the 3 coordinate, and that is called degrees of freedom. Okay. So in this way, these are the things which we are discussing. So for a system of n particle, the constraint moving independent of each other has a 3n degrees of freedom. Okay. So if you are having n particle, if you are moving in the space, so how many degrees of freedom it will have? N particle, right? So if you are having 100 particle multiplied by 3 coordinate, right? Each and every particle will have 3 coordinates, na, x, y, z. So combining all this, it will be 3n degrees of freedom. Okay. So this next one is generalized coordinates. So what is generalized coordinate? It is nothing but the set of linearly independent coordinate to describe the configuration of process by taking account into of the constraint. Okay. By considering the constraint, it is nothing but linearly independent coordinate. जो भी हम degrees of freedom में लिया था, वही हमको यहाँ पे consider करना है. Okay. So if you are having a particle in this plane, what are the generalized coordinate? Only 2, x and y, right? If you, next is if suppose that particle is in the circle, okay, if I am saying that particle is in the circle, so what is the restriction? X square plus y square is equal to some r square, right? So x and y are the coordinate, and x square plus y square is equal to l square is a constraint. Okay, that is what a restriction on the particle. So hence it will be not depend. They are depending. No, x square plus y square is equal to l square. So x and y, they can be expressed in terms of each other. So hence we cannot say they are linearly dependent. We can say they are linearly dependent. Okay. So if they are linearly dependent, so hence we cannot say that the particle, how many particles are needed for a motion on the circle. So simply one particle will be required, because x square plus y square is equal to l square or r square. So if you are knowing x, you can find out y. So that is what a dependent is. So a set of linearly independent coordinates which are used to describe the configuration of processing by taking into account of a constraint is called a generalized coordinate. Okay. So here we have seen, if you are having 100 particles on the space, and every particle will have 3 coordinate x, y, z. So that is called a 3n number coordinate, but they are related with L equation. And if we are saying that the distance between them is constant and something else, That means they are related by L equation. So we can say 3n minus L will be the linearly independent coordinates. Okay. So these are the examples that we can consider. Okay. So we'll see this in the next lecture. Thank you. Actually, net connection is going, so that's why I'm ending the lecture. Thank you, everyone.